So apart from 0, 1 by x is continuous set. Okay.
Okay, sir.
Yes. Okay, so yeah, any other thing from week 8? Can start asking your doubts from week 8. Any kind of doubt if you have in week 8, you can ask and start raising your hands. Anurag. Hello, Anurag. Anurag Dubey. Suman.
Yes, sir. So my doubt is on activity question 8.3. 8.3. Yeah, 8.3 activity question number 6.
Question number
6.
6.
Yeah.
Yeah. So when
yeah, see, among the 4 options, I found the last one to be correct, but they have given 2 options. So ideally, they are referring one among the first 2 options seem to be correct, but somehow I couldn't derive that as a solution for log 5 base x.
Okay. So there are 4 statements, right?
Yes, correct.
So one thing that you are sure that the last statement is correct and the second last statement is incorrect, right?
Correct. Yes.
Yeah. So the only thing you need to check, like in between the first 2 statement, which is correct, right? So the common function in the first 2 statement is this one, right? Correct?
Yes, correct. Yes, correct.
So again, like, see, the thing is, so as you said, in your last option, what you have? ln.
Yeah. Last option is
ln x square, right?
Yeah, ln x square. Yes.
And so here the advantage is here the base is e, right?
Correct.
And you know how to derivative this function, right?
Yes.
Because if you differentiate it, what you will get? 1 by
x.
X square.
Yeah. And it will be
times
2x.
2x, right?
Yeah.
So which is 2 by x, right? So so now the problem with this log here, whatever here, it is not in the form of base e, right?
Yes.
So what you can do, you can change this to base, right? So what I can write instead of this, I can write this as log base c. So in particular, I can write this as ln 5, okay, log.
Yeah, by log ln x.
What is e
X.
x, right? That is basically ln x. Right?
Yes.
So this is okay. Let me write in this way. So the thing is, this is basically ln 5 by ln x, right?
Yeah.
Now this is a constant, right? Whatever is the in the numerator, that is a constant, right?
Constant. Yes. Yes.
And the only function, like is in terms of x is this one, the quantity which is in the denominator, right?
Yes.
So now I just, so if I differentiate this, right? So if I differentiate this thing with respect to x, right? So I need to differentiate this one, right?
Yeah.
So if I differentiate, then this will come out, right? Because this is a constant.
Yes. Constant.
So I just need to differentiate this function. Now, can you tell me how I can differentiate this one?
Log e of x.
So in particular, what is this? This is precisely log x base c times minus 1, right?
Yes. Yes.
So if I differentiate this, then what I will do?
Minus 1 would come in the front, and it will become log e or x whole minus 2. Sorry, okay.
Correct.
Log e x whole power minus 2. And log ex will become, I think it was ex only, right?
So what is this? So you are basically, you need to apply the chain rule, right? Then see, so then again you have to differentiate this function, right? Forget about the power. Yeah. So if you differentiate this one, then what you will get? 1 by x, right?
Oh, okay. Yeah, 1 by x, correct. Yeah.
See, what is the derivative of log x? Ln x.
Yeah, 1 by x. 1 by x. Yes.
1 by x, right? You will get 1 by x. So,
yes.
So if you write this, what you will get? Minus log 5 e, right? Square, right? So I can write this as log times x, correct?
Yes.
Now this is the answer. The thing is, now you need to check which of the following option, okay, whatever is given there, it's same as this one. See, now I can write this quantity, right? This is what?
Log 5 base x.
Correct. This is basically log
5 base x.
5x, right?
Okay.
And then what is this? Log ex, right? Times x. Now I can take this thing into the numerator. So if I take, then what will happen? The base will change, right?
Change. Yes.
So now you can see which one is matching with this one, right?
Yes. Now it's matching with the answer. Sir, yeah, but the approach I have taken is, since log x, 5 base x can be written as log 5 by log x, like ln 5 by ln x. Then I was applying the quotient rule there. I think that is where I was going into f, a derivative of log 5 into log x minus.
Sorry, so you are applying the quotient rule.
Yeah.
To this one, right?
Yes. Correct.
Yeah, tell me how you have applied the quotient rule.
So it is f.
Okay, first tell me what is quotient rule.
It is.
Suppose you have this.
X.
Tell me.
Yeah. It is f dash of g, that is a derivative of x into g of x into g. Yeah. G of x minus derivative of g of x
Hmm.
into f of x
Hmm.
by g of x whole square.
Yeah. Okay, so now if you apply, then what will happen? What is your f here? F is constant, right?
F is constant, yes. Yes.
This is your f.
Yeah.
And
so
this is your
0.
g, right?
Yeah.
So
Yeah.
now if you take the differentiation, f dash x is what? Basically
0. 0, right.
So this will give you 0, right? So basically you are here, like in
Yes.
the second. So this
Yes.
is minus times
Yeah.
1 by x, right?
Yes, correct. Into
Divided by
square
ln
log
x
whole
whole
square.
square, right? So we are getting the same thing, right?
Okay.
Right? So this is what we are getting, right? See this, what is the derivative of this thing?
Okay. Okay.
What is the derivative of this thing? We are getting this one, right?
Yeah. Okay. Yeah.
And you are getting the same thing, right? What is this? This is what? See, this is what basically you are writing. This is a by b divided by, this is your c by d, right? So if you write this is what? A by b times d by c, right? So if you write the whole thing, okay, what you will get? You will exactly get this quantity, right?
Got it. Okay.
Yeah.
Yeah.
Clear?
Yes,
This
very
one?
good. Yeah, clear. I have another doubt
in
the same activity, that is question number 3.
Question number 3.
Yeah.
Yes. Yes.
Yeah. So
what is the function? First tell me. F of x is equal to x time mod x, right?
Modulus of x, yeah.
So what you want to check? What is your doubt? So first tell me whether this function is continuous.
It's continuous, yes.
Because it's the product of two continuous functions, right?
Yeah.
This function x is continuous, right? And mod x is also continuous. And I'm basically taking x is continuous on whole R, right? And mod x, you know the graph of mod x, right?
Yeah. Yes. Yeah.
This is continuous on whole R, right?
Yes.
So the product is continuous on whole R, right?
Yeah. Yeah.
And the next thing is differentiability, right? You know that x is differentiable on R, right?
Yes, it's differentiable
on R, right?
Yes.
But the problem with this function, right? Mod x. Mod x is differentiable on R minus 0, right?
Yes.
So if I take the product of x and mod x, okay, so one thing I can say that my function f of x is differentiable on R minus 0, right? So the only problematic point is this point 0, right? So I just need to check whether this function is differentiable at 0 or not, correct?
Yes.
Yeah. So first thing is, you know that if I consider this mod x, right? So mod x has two possibilities, right? It depend on the sign of x, right? Correct?
Yeah, correct.
So this is x if x is greater than 0, right?
Yes.
And this is minus x if x is less than 0, right?
Yeah. Yeah.
So that means I can write my f of x. If I split my f of x, then basically I am in this situation, right?
Yeah.
0, and it's
Yeah.
minus x square, right? So this is
Yeah.
my function. So my next target is to check whether f is differentiable at x equal to 0, right?
Yes.
Okay, so now if you apply the definition, okay, what you need to check? So here your a is what? A is 0, right?
Yes.
So if I apply my definition, I just need to check whether this limit exists or not. Limit extends to 0.
Yes.
F of a. So here a is actually 0. 0 plus s minus f of a, which is again it's 0 by s. So I just need to check whether this is exists, right?
Yes, sir.
So this I can write now, limit s tends to 0, f of h, right? Because a is 0, right?
Yes.
Now I have in so this limit, right? So what basically I mean by this limit exists? The left hand limit should exist, the right hand limit should exist, and this both of them should be equal, right?
Yeah. Yeah.
So what is left hand limit?
It's
Limit s tends to 0 minus, right?
yes.
F of s minus f of 0. Now you tell me what is, so when s tends to 0 minus, what is f of s?
When it tends to 0, then you are asking f of h, right? Yeah, f of h should be minus minus 2x, right?
Not minus 2x. What is, if x is less than 0, what is f of x? Minus x
minus
square.
x square, yeah.
So that means, so when you are coming to 0, so this is your 0, when h is coming to 0 from the left hand side, right? That means h is negative, right?
Negative, yes.
So this should be minus of h.
Minus of x. Okay, okay.
Correct?
Yeah, yeah.
And f of 0 is of course 0, right?
0, yes.
Now what is this limit?
Limit is minus h, right? It is.
No, so limit of h, and where h is going towards 0 minus.
Yeah.
This should be 0, right? What is limit of
okay.
x as x tends to 0?
That's 0.
That is what I'm writing, right? So instead of x, I have h here. That's all, right? So what actually I'm doing? I'm saying what is the limit of h where h tends to 0 negative. So I'm coming to 0 from this end.
Yeah, yeah.
Left hand side. That means the limit will be 0. Okay, right?
Got it. Okay.
So the next thing is the right hand limit, right?
Yes.
And by the same logic, right, what you can write. So, okay, so I made a mistake here. This should be minus.
Minus,
right?
yeah.
Yeah. So again, this should be minus, right? But again, it's not going to affect anything because you are going to 0. 0 negative, 0, they are basically the same.
Yes.
So now again, by the same logic, this is 0, right? So the left hand limit and the right hand limit, they're same, right?
Okay, okay.
That means this is your 0, right?
Got it. Yeah.
This is your 0. And what is this? This is your f dash of 0, right?
Yeah.
So now you can easily find out the derivative, right? So now if you differentiate, what you will get? So if x is
2x,
this is 2x.
Yeah.
If x is less than or equal to 0, because see, at 0 it's 0, right? So if you substitute 0 also, you are getting 0, no problem. Okay, you can write x is less than or equal to 0. This is minus 2x.
It's if x is greater than or equal to 0, it is 2x, right? Okay. Yeah. It's greater than or equal to 0. Yeah. Yes.
So this is your derivative. Yeah.
Yeah. Got it.
Clear, right?
Yes. Yes.
Okay.
Yes.
You have any other doubt?
Yeah. If others don't have, probably I have few more.
No, I don't see any
Okay.
hand. Okay.
Okay.
So you can ask.
Yeah. So the on the question number 8.
Which one? In the same.
Same activity. Yeah.
Mm-hmm.
F of x plus y is equal to f of x and f of y for all x, y, element of R, and f of 9 is equal to 6 and f of 0.
Just a minute. A minute. This is what it's given. Then next, f of
9 is equal to 6 and f dash of 0 is equal to 4. Then f dash of 9 is what is the question?
Okay, so the question is what is you, so these are the things that function satisfies, and you need to find what is f dash of 9, right?
Yeah.
Okay. So it's given that f of 9 is 6, right? That means f of the function is not a zero function, right? Because so what basically I mean by 0, that f of x is equal to 0 for all x, right? So clearly this is not a zero function, right? So now this condition, okay, this condition holds for all x comma y in R, right?
Yes.
So that means I can write f of 9 plus 0 is f of 9 times f of 0, right?
Okay.
That means f of 9 is f of 9 times f of 0, right? So this is 6, correct?
Yes.
This is also 6.
6, yes.
What basically this implies? F of 0 is what?
F of 0 will be 0 only, right?
No.
Oh, okay. 1 minute. Why is f of 0 could be x, is it? Or
see, okay, see what basically you are getting 6 equal to 6 times f of 0, right?
Okay.
That means f of 0 is equal to 1.
Oh, okay. Yeah.
Right?
Okay. Yeah. Okay.
Correct. So so now you have f of 0. You know the value of f of 0, right? No, so that is the extra thing that you have computed. Okay, you know what is f of 0, right? So now you need to find f of f dash of 9, right? So,
sir, before we get into that step, how you substituted f of 9 plus 0, the previous step. How like what is the idea? Like how?
Which one you are saying?
The step, first step, f of 9 plus 0. Yeah, that one.
This is given, right?
Yes.
This is true for all xy, right?
Correct.
So in place of x, I substituted 9. Okay.
Yes.
In place of y, I substituted 0. Right.
Okay, is that because they have given f dash of 0 is equal to 4, so we chose 0, or any particular reason why we have?
Yeah, so you'll so when actually see the thing is, when you'll try to compute this, okay, you'll see why actually we are computing f of 0. Okay, so when you will try to find this f dash 9, right, then only you can realize why actually we have computed f of 0. Okay, so when you write down the definition of f dash of 9, okay, as soon as you write the definition of f dash 9, you will see why f of 0 is essential. Okay.
Okay.
So this calculation is fine to you, right?
Yes, that is fine.
Okay,
yes.
so let me first write what is f dash of 9.
Yeah.
So what is f dash of 9? Limit s tends to 0, f of 9 plus s, right?
Yeah, okay, f of 9 by h.
x, right?
Yeah.
So what is this one? By the property of my function, what is this one? F of 9 plus s.
F of 9 plus h. As h tends to 0, it is f of 9, right?
No, that is true. Okay, so that is true when f is continuous. Okay, in general, it's not true.
Okay. Yeah. Okay. So
no. What? See, what I have done here.
Oh, okay. Yeah, I got it. So if it is f of 9 plus
9, not plus, times f of x, right?
9 times f of x. Yes, correct. Yeah.
So
yes. By h.
Right.
Yeah.
So now I can take f of 9 out.
Yes. F of h minus 1. Okay.
Yeah. So now you said, right, why actually we are interested in f of
0, having 0, yeah.
0, right? So again, like, see, the thing is, so we are using derivative, right? And as you can see, this is already given, right? This is given, right?
Yes.
And we already have a term which contains f of 9, right? So if you see, like, then somehow, since this is given, right, this is given in the question, right? So somehow you have to use this one to compute the value, right? So that means somehow you have to write this thing, okay, in terms of, right,
Dash of 0. Okay.
correct.
Okay. What we mean by writing it in terms of f dash of 0?
This term, whatever it is.
Yeah.
Okay, can you write in terms of f dash of 0?
Okay. That is by applying. So we are considering here h as 0 when you say f dash of 0. Is it right?
No.
Okay.
What is f of 0?
F of 0 is
Here
it's 1. Yeah.
1, right? And you have 1 here, right?
Okay. So
this you can write limit s tends to 0. Just see what I'm doing. Correct?
H tends to 0. Yeah. Okay.
By definition, what is this one?
This is f dash of 0. Yes.
This is f
dash of 0.
Right?
Okay.
So the whole thing is what? F of 9 times.
Yeah, f dash of 0. Okay.
Now you have the answer, right? Because
Okay.
this is known, this is known.
Yeah. Yeah.
Oops.
Okay. 6 into 4. Okay. Okay.
Okay. Anything
Yeah.
else? I still don't see any.
Yeah, I still have few more.
Yeah, please, you can.
Yeah. So, yeah, on 7th question, the previous question to this, I found the third option is right, and I found even the first, all first 3 options as right, but I don't know why the first option is wrong. Like, because
Yeah. Okay. So can you tell me why you feel this?
it's wrong.
The first option is correct. Limit extends to 0.
Yeah,
X plus
x by x plus sine x.
Yeah.
So the question is asking, when we will apply L'Hopital's
Yeah. When we can apply the
yeah. So when it is coming in a indeterminate form, then we will go for L'Hopital's rule, right?
No. So okay, right. See, the thing is, when one can apply the L'Hopital rule to find out the limits, right?
Yes.
So if you apply I agree that this is coming in indeterminate form. Right?
Yes.
But
yes.
if you apply the L'Hopital rule directly, can you get the limit?
If you apply, because derivative of x is 1 divided by 1 plus sine x will be 1 plus cos x. X, yeah, we would get right.
No.
Is it okay? So 1 by 1 plus cos x.
Now whether this is in indeterminate form?
Cos of infinity. Cos of infinity is what? Is it? Basically, we have to find cos of infinity right here to.
Yes, but that limit doesn't exist, right?
Yes. So we can assume that cos of infinity is also infinity, right? Infinity or
no,
0.
cos is a bounded function.
Okay.
See, this thing is this you can check as x tends to infinity cos x. Okay.
Yeah.
This actually does not exist.
Okay.
So this limit actually doesn't exist. Okay. So in particular.
Okay.
So if this limit doesn't exist, that means you cannot apply the L'Hopital rule directly. Okay, to get the limit.
Okay. So so it's not only indeterminate form. We have to see if by applying the L'Hopital's rule, will we get
what L'Hopital rule says? See, so when this is in indeterminate form, okay, let's say x tends to infinity, you have f of x by g of x. Okay. If this is in indeterminate form, and the second thing is this should exist, right? This should exist. If this is L, okay, then if this is L, then this is same as L.
Yeah,
right? So
correct.
If this doesn't exist, then L'Hopital rule says nothing. Okay. L'Hopital rule is applicable when this is exist. Right.
I see. Okay.
If this doesn't exist, then certainly can't say that this limit also doesn't exist. Okay, that you cannot say. Okay.
Got it. Okay.
You can only say that I can't apply this rule now. Okay, because since this limit doesn't exist, then I cannot apply. Okay, I have to go for some other way. Okay.
Got it.
So that is what happening here.
Okay.
Since this limit doesn't exist, I can only say that okay, my L'Hopital rule the way I am applying now here, I can't conclude anything about this limit. Okay, I have to maybe this limit exists, or maybe this limit doesn't exist. Okay, certainly I can't conclude from L'Hopital.
Okay. Yeah, got it, sir. Thank
So,
you.
sir, how can we find that limit? Limit x tends to infinity, x upon x plus
You
sin x.
divide both the things by x. Okay, both denominator and numerator. Okay, if you
Okay,
divide this,
we go by conventional method.
yeah. You just slightly need to modify this. Okay, certainly this limit is 1. Okay. But if you directly apply the L'Hopital rule, you won't get it. See if you write, then what you will get? If you divide 1 plus sine x by x, right? If you divide both denominator and numerator by x, you will get this thing, right?
Yeah, right, sir.
Yeah.
So what is this limit?
That is 1, right?
No.
One.
This is 0. See, you need to differentiate between two things, right? Limit x tends to 0.
0 and x tends to
Okay.
infinity.
Sine x by x is 1.
1.
Okay, but limit
Tends to
when limit
infinity, then it is 0.
infinite, say sine x by x. See, sine x is basically it's always less than equal to 1, right? So if I if I divide x, okay, so sine x is always less than equal to 1 and greater than equal to -1, right? And if I divide x, I'll get this sign, right? Now, if you take x tends to infinity, minus x sin x by x 1 by x. This is 0, right? This is 0, right? So by sandwich lemma, you will get this to be 0, right? So now if you apply this limit, then this is 1, right? Correct?
Yes, sir.
Correct.
Yeah.
Again, like, yeah, so you have to so as I said, from L'Hopital rule, actually you can't conclude anything, but if you slightly twist your representation, then you will get the limit as 1. Any problem with this part? Is it clear to you now?
Yeah, it's clear, sir.
Yeah. Okay, Saad, do you have any doubts?
Yes, sir, I have some conceptual doubts.
Mm-hmm.
Like, I have gone through week 8, and what I have learned so far is at some point x is equal to a, when left hand limit is equal to right hand limit is equal to f of a. Then we can say at that point x is equal to a, the function is continuous, right, sir?
Right
But
hand limit? Right
yeah,
hand limit is same as
RHL is
left hand
equal
limit.
to, yeah, RHL is equal to LHL is equal to f of a.
Correct. Yes.
If this condition meets, then we can say at point A, the function is continuous. Right,
Correct.
sir?
Correct.
Yeah, but in question, if it says like if the function is differentiable at x is equal to a, can we directly say that f is continuous at a?
Yeah, of course. Right.
Okay, so so at some point, continuity and differentiability are linked.
See, the thing is, differentiability is a higher thing. Okay, so differentiability always implies continuity. Okay, so if your function is differentiable, okay, differentiability at x equal to a, okay, it's always implies that the function is continuous at x equal to a, right?
Okay, sir.
So differentiable, like, see, the thing is, okay, so if you have a function, okay, which is not continuous at x equal to a, from there itself you can directly say that the function is not differentiable at x equal to, because from this statement, right? Because differentiability always implies continuity, right? That means if my function is not continuous at x equal to a, okay, that means I can say that my function is not differentiable at x equal to, because if the function is differentiable, then it should imply that the function is continuous as well.
Yeah, it must be continuous
Yeah,
because
since, yeah,
differentiability in other terms we are finding tangents, right?
yes,
Slope
correct.
basically. So if the graph is broken somewhere, so we cannot find the tangent. Okay, so got it.
Yeah. See, the thing is, when actually, so in such situation, when if you consider this function, okay, so if the graph is broken, okay, in some sense, then the function is not continuous, okay. Even the graph is not broken when you have some corner points, right? If you consider this function mod x, right? Here, this is a corner point, right? At x equal to 0. So this, if you see the graph, this graph is actually continuous. It's nowhere it's broken, right? But since it has a corner point, this function is not differentiable.
Got it, sir.
But if so see, so here you can't conclude anything about the continuity. You have to check it. Okay. Of course, you can, by looking at the graph, you can say that this function is continuous at x equal to 0. But it's really easy to tell a function like this. Suppose you have a function like this, okay, and let's say from here you have something like this, okay. So here, as you can see, there this is broken, right? This is not continuous, right?
Yes, sir.
Since this is not continuous, you don't have to check the differentiability. This
For
should imply that this
differentiability,
is not
right?
differentiable.
So if it is continuous, then we have to check for differentiability. But if it is can be differentiable, then we can surely say that it is continuous at that point.
Continuous, yes.
Okay, so one more thing regarding tangent, finding tangent, the
Hmm.
last topic of week 8.
Hmm.
Practice assignment question number, it is hold on, it is tangent. I'm not getting that question. Basically, the conceptual doubt is if we have to find the tangent, right, sir, on some point,
Hmm.
so we have to do like linear approximation at that
Hmm.
point, right?
Hmm.
So
Hmm.
instead of going by that formula which is provided, if we find the slope at that point, basically differentiate at that point and
That
get by
is,
point
yeah.
slope and get by point slope formula that tangent line ka linear equation.
That is
Uh,
that
it-
is actually that is how
yeah,
you are
that is
actually
actually,
getting.
but sir, the answer differs, sir. I don't know why the answers differ because if we go by linear approximation formula, I am getting the answer, but if you go to by that concept which I just described, I'm not
Uh,
getting the answer. That's why I ask you, is there any
no, you
difference
should
among
get
this?
this. At least we should get both the answer. Otherwise, otherwise you are making some mistake. Otherwise, we have made some mistake while computing. See, so basically the idea is, suppose you have a graph like this, right? So, and let's say this is your point A, right?
Yes, sir.
That
It's question
that
number 5, sir. Practice
uh,
assignment question
yeah,
number 5.
I'll come to that. So just a minute. So this is your A comma F, right? So
Right, sir.
so when you are differentiating the function at A, what basically it's giving?
I'm getting the slope, sir. Yeah.
Yeah, you are actually getting the slope of this line, right? The
Right, sir.
slope of this line is f dash a, right? Now,
Right.
and to get, so you need to know the equation of this line L, right? No, you just need to
Right,
find
sir.
equation. So now you know that this L, whatever this L is, L passes through this point, right?
Right,
And
sir. So we
and
have one
this,
point and one slope,
yes,
and then
and
we can
then,
find the linear
yeah,
equation.
yes.
But
This.
the answer differs. Can you check question number 5
Yeah.
of practice assignment? It would be great.
Okay. The linear function. This is the best up. The base of f of x. F of x is e power x minus 1, right? So,
Right, sir.
yeah.
The
So,
first option, only first option.
f of
The
x is
linear
equal.
function of ex minus 1 is the best linear approximation of the function fx at point x is equal to 1.
Right. So this is your function, and what you need to find? You need to find the tangent line at x equal to 1, right?
Right, sir.
So then my point, this a comma f of a is precisely 1 comma f of 1, right? So in that case, what is f of 1? F of 1 is 1 e minus 1, right? Correct.
Right, sir. Okay, okay.
Uh,
Now I got it. I took y is equal to 0. Okay, sir.
So
I
in
got
that
what
case,
I'm doing wrong.
yeah.
Yeah, yeah, yeah.
Yeah, this is
I took
0
y
at,
is equal to 0. That's why I'm not getting it. Because
so
there is no mention of okay.
this is 0 at this is okay, f of 0 is actually 0. So f of 1 is e minus 1. So I guess, yeah.
Yeah, yeah. I got what I'm doing now. Thank you, sir.
Yeah. Anything else, or like,
No, sir, not yet.
okay, fine. Okay, so Maria.
Sir, I actually had a doubt in grade assignment 7. Is this only for week 8?
So which graded assignment? Which week?
7, 7, 7.
Seventh week. Have you checked the solution?
Sir, solution is not given yet.
Just a minute.
It is in supplementary contents, Maria.
I guess no.
It's only till week 6.
Yeah. It's not there. It's there. Okay, I'll tell. Upload it today itself. Okay, so before that, let me check. Week 7 graded assignment, right? Question number what you said?
Question number 4, sir.
Okay, 4.
I just had a doubt in the second function. Because
Just a
that
minute.
is
Let me
that
share my screen. Just a minute.
yeah.
Right. This is your question number 4, right?
Yeah.
In curve 2, you have problem or what? What is
Yeah,
your
sir, curve 2, I actually had a doubt. That is does not have a unique tangent, right?
Yes.
So, what is the exact reason? Is it
Sorry.
because what is the reason it does not have a tangent? Unique tangent?
You are asking the region, right?
Yeah. And
Okay.
sir, it's given as 0 points. The question is that a mistake or
Just a minute. What basically saying in the
You
graph?
cannot find the unique tangent at sharp end.
How many curves have unique tangent? Certainly, this has curve
At
one.
origin.
Curve one has also no unique tangent. Curve 2 has no unique tangent.
3 and 4 having each other? Sir, why is it given as 0 points also? That also I didn't understand. Is there a mistake in the question?
No. Can you repeat? I don't. Why it is given?
No, sir, it's given as 0 points. It's not graded.
This is graded, right?
No, I think she is referring to the score given to that question.
Yeah,
It's
sir.
0
Yes, sir.
points. So yeah, I think for everyone it has come as, even though the answer is right or wrong, it's 0 points for everyone. It's there in the bottom of the question, sir. If you in the right hand corner, you can see. Yeah.
So I was wondering if there's a mistake in the question. Answer is 2 itself, right?
Okay, so okay, I guess I don't know. I have to check. So the problem is actually probably this curve 3. Okay. So what is the problem actually with the curve 3? Certainly it has, you can say actually it has a tangent, but if you know in some sense you know differentiability, then you can say that this function is not differentiable. This is differentiable, right? This is
I think they have given 2 curves as differentiable. The answer says 2.
This is the graph of x cube, right?
Yes.
Yeah, f of x equal to x cube.
One is x square, another one is x cube.
Yeah, x cube. Okay, so if it is x cube, then
yeah, I think if you scroll down, sir, the answer is 2, right? Can you scroll down a bit?
No, answer is fine. So
yeah, 2 of them. Yeah.
Because certainly this is
A and B. Yeah, 1 and 2 is out. I think 3 and 4 is.
Sir, is unique tangent linked to differentiability? Like,
sorry.
is unique tangent linked to differentiability? Like,
Yes, unique tangent means the function is differentiable at that point. Yeah, that is the same thing. Okay. Unique tangent means the function is differentiable. Function is differentiable means it has a unique tangent.
is the point given as 0 because it's not like in week 7? Because I had a doubt. There was another question where they're asking about unique tangent also, I think.
Yeah, I'll check. I don't know like who made this. Yeah, I have to check with the portal. Okay, why this is actual 0 function? Because the question is correct. Because this is f of x equal to x3, that means yeah, the derivative is 0. Okay, yeah. So this has a unique tangent at 0, 0. This should not be a problem. Yeah.
Sir, so if the question is is there a tangent, then also the answer is 2.
Then yeah, that is what I'm saying, right? See, the derivative and the tangent, they are basically the same thing. Unique tangent means the function is differentiable at that point. Okay, and if a function is differentiable at that point, that means you have a unique tangent. That's all. Okay. They are basically equivalent. I'll check with this part.
Okay, sir. Also, like if the solution is available, it would have been good. Like,
yeah, we'll upload it today itself. We have the solution. Probably we forgot that portal team. I guess they forgot to upload it. We'll upload it today.
Okay, sir. Thank you.
Sir, I have also doubt in same grade assignment. So can you go to question number 1? Sir, is option 6 exactly correct? Because none of the graph is matching from the equation. I put it equation in the Desmos.
1, 2, 3, 4, 5, 6.
Yeah, that's option.
Third goes to a 3, right?
Yes, sir.
Goes to a exponential function, and no, this should match, right?
But sir, you can put it on Desmos and it is exactly the curve is on y-axis, exactly on y-axis, not behind this.
Exactly on y-axis.
After putting it on Desmos, you can also understand what I'm saying, sir.
Just a minute. See, the problem with the magnitude of this, in some sense, the scaling of this, what the graph. Okay, so if you put in Desmos, then this, okay, you will get a slightly better. Plus 7, right?
Yes, sir.
I don't know why it's not coming here. Right? This is what you are getting, right?
1 second, 2 Rx. I think I made a mistake in putting it.
See, the thing is, this is basically that now this is the horizontal tangent 7, right? So if you go back to the question, actually here, as you can see, this basically starts from 8. Okay. So that's why this this part is missing, whatever gap you have here, because you are seeing a bigger picture. Only difference is in the scaling. Okay. Apart from that, everything is fine. Got it?
Yes, sir.
Okay. Okay, anything else? Any doubt
Yeah.
from?
Yes, sir. I have on activity 8.2. That's the second question I have doubt. The doubt is, why the first option is wrong and the last option is right.
Okay, the first. Okay,
okay.
just I don't have to write here.
Yeah.
You can see the question, right,
Yes.
in the screen. So
Yeah.
what basically it says, you have a constant function, right?
Function, yes.
So limit s tends to 0. Okay,
Yes.
f of a plus s minus f of a divided by s, right?
Yes.
So this part is fine. This
Yes.
part is fine, but the problem is the next part. If you see, what is f of a plus s? What is f of a plus s?
C only, right? Because
but they have, it's written something different, right? C plus s it is written, right?
okay. Yeah. C, okay.
See, this is a constant function.
Yes.
Eventually,
Yes.
if you differentiate
H will
it,
not
you should get 0, right?
Got it. All right. And see, in the last function, the doubt I have is up to the second point, it is okay. The where e power a, and they take e power h minus 1 divided by h, and when they are saying limit h tends to 0, e power h minus 1 by h, it should be 0, right? Why because e power, when h tends to 0, e power 0 will be 1.
You are this is in your indeterminate form, right?
H is also 0. Yeah, it is in indeterminate form.
Now you apply L hospital rule here. See what you are getting.
Okay, so it will be e power. So numerator will be e power h minus 1, which is, when differentiated, it will be e power h into h. If we differentiate h, will it be 0, sir?
No, 1.
1, right? Okay.
Because here the variable is h, right? So you need to differentiate with respect to x.
We have treated it as x. Okay.
Yes.
So it will be 1. So it will be e power h. 1 will become 0. So we will keep e power h, and g will become 1. So it will be e power h into h minus e power h minus 1 into 1 by h square.
No, I guess you are making some mistake.
What is?
See, what is, just a minute.
Yeah.
what actually you are computing? You are computing this, right? Limit s tends to 0.
E power h minus 1 by h.
So this is 0 by 0, right?
Yeah, but
so if you differentiate it, what you will get? Limit s tends to 0,
0,
e
then
power s, right?
oh, okay. Sorry, I went into
This
quotient
is
root.
the
Okay.
derivative of e
Yeah,
by
e
s.
yeah.
This is 1, right?
Okay, it is e power h. Yes.
So this is 1, e power 0.
So it will
right?
become 1. Okay. Yeah, it will become 1. Yes. Got it.
Okay. Whether which two will be confined to 5 to 8 only. Okay, so yeah, so most of the question basically it will come from not most of the question. So you actually will not get any direct question from week 1 to 4. Okay. You will get all the question from week 5 to 8. But some of the concept maybe you may need some of the concept. For example, in week 5 you have functions, right? One function, 1 2 function. Even the same thing you have studied in week 1 as well. So yeah, so in some sense there some kind of concept overlap, but will not give any direct question from week 1 to 4. Yes, okay. Anything else? Any other doubt?
Sir, inverse of a differentiable function is differentiable, right? Is not the case?
No.
Okay.
Like think you can try. Let just think about this example.
Cube 3x square.
So this is a function. Of course, this is 1 1 and on 2, right?
Yes.
Think about take the inverse of this function and check the differentiability of that function.
Yeah. Got it. Yeah, I will check, sir. Sorry. I had to...
Yeah. Okay, any other doubt? So if you don't have doubt, then probably I'll stop the session. I'm not going to continue it.
May I ask something?
Yes, please.
Sir, I have just doubt related week 6 and 7. They will upload the live sessions video.
Yes, I guess so.
When, sir?
Sorry?
Before quiz 2, will they upload a live session?
Revision session you are asking or what?
Revision session will they conduct it?
Will be conducted.
But the already session with of live session week 6 and 7, they only give the PPT of it. But not the live sessions videos.
Okay, you are saying the videos are not there in the YouTube.
Yes, sir.
On all the session or like some of the session?
No, only for live sessions like this.
Yeah, what I'm saying, all the live session videos are not there, or some of the live session videos are missing. I'll check.
All live sessions are there.
Okay, all live session you are saying. Okay, then I will check. Okay, I'll check with the team.
Old of Solve with Us week 6 and 7 will already uploaded. But recent which will conducted, that will not upload. Let's see.
Okay, I'll check with Subham. Yeah, I'll check and probably let you know in the next session. No.
Sir, when will be the summary of week 8?
Summary in the sense, what do you mean by summary? The solve with a session or hello?
So, I mean, the summary of the whole topic of week 8.
Hello.
Hello, sir. Am I?
Hi, but in session we usually don't give the summary of the week, right? Probably
But I
in the
guess,
Mhm.
but I guess in week 7 actually it had happened. The summary.
I don't know. Like certainly we don't do it for all the weeks. Okay, probably in week 7 it happened, but before week 7 we never. At least I never gave the summary of all the weeks. When basically student asked, I explained according to the questions of the students. Probably in the next class. Okay. I so I can show some this differentiability in GeoAlgebra. I have prepared a few things, but again, it's not the complete. Okay, any other doubt from week 8?
Sir, can you please explain the concept of linear explanation?
Linear approximation, right?
Yes, sir.
Yeah. So just now someone asked, right? So how you compute basically? So what basically mean by linear approximation? Okay. Suppose you have a function like this. Let's say you have, okay, let me take some easier function. Suppose you have a function. And this is the point A. Okay. So what you want, so you want to approximate, so this is the graph of this function. This is the graph of this function f. So what you want to approximate this function at this point A, right? At this point A using some linear function. Okay. So what is the best way to do to approximate this function? Okay. Of course, when this function is differentiable. Okay. And why? Because if the function is differentiable, then I can talk about the tangent, right? So the tangent of this function at A, okay. So if I consider the tangent, this basically touches this point. Okay. If I consider this tangent of this function at this point, right? At A comma f of A, right? Is precisely the best linear approximation of this function at x equal to A. Okay, so this, whatever this tangent is, this tangent is the best linear approximation to the function tangent at a comma f of a is the best linear approximation to the function at x equal to a, right? So how you can get, so the thing is, the only thing you know that this tangent passes through, so tangent, this, whatever this tangent, this is a line, right? This is a line. Who asked this question? Are you here or?
Yes, sir.
Yeah.
Yes, sir.
So this is a line, right? Hello.
Yes, sir.
So yeah, so this tangent is a line, and you know that this line L passes through a comma f of.
Yes,
And
sir.
why actually we are basically we are considering this differentiable function, because if the function is differentiable, then basically we have a unique tangent, and by using the property of the differentiability of the function, we can get the slope of this line. Okay, we can get the slope of this line, and the slope of this line is nothing but slope of the line slope of L is f dash, right? So now you can compute the equation of this line, right? Whatever this line L is, you can compute the equation, because you know that the line passes through a comma f of a, right? And the second thing, you know that the slope of this line is f dash a, right? So then the equation of this line will be y. So you know y equal to mx plus c, right? So what is your m now? M is what? F dash of a.
Yes, sir.
Right? So that means y equal to f dash of a x plus c. So only thing you need to compute this c. And to compute this c, you need to use this thing, right? The line passes through this point, a comma f of a. That means at a, the value of this line, the line produces f of a, right? So if I substitute this one here, then what I will get, f dash a times a plus c is f of a, right? And c is what? F of a minus f dash a times c, right?
Yes, sir.
So then you will have the equation of the tangent line. Okay. So the only thing you need to find is basically the value of the function. Okay, if you find the value of the function, then this will give you this point, right? And the next thing is the derivative of the function at that point. Okay, once you know these two things, then automatically it will give you the tangent line. And this tangent line, whatever you have asked, the linear approximation, the tangent line is precisely the best linear approximation of this function. See, as you can see, this what basically means, if I take the tangent, then see the value of this line is very close to the value of this function near to this a. If you consider this interval, okay, the value are basically, they are really close. So that's why that's why we're calling this as a linear approximation. Okay, so in a small interval containing a, okay, the value of f, okay, the value of f of x is very much it's very close to this L of x.
Okay, sir. So what is Alex here?
This line, this.
Oh,
Okay.
yes.
Yeah,
Okay.
I made a mistake. This line. Oh. equation of this line at it's better to call at A. Okay, L of A.
Yes, sir.
Okay.
Okay, got it.
Hello, sir.
Yeah, Siddharth is.
Yes, sir. I have doubt in activity 8.1, question number 5.
8.1.
Yes, sir.
Question number 5. Yeah.
Sir.
Which part you have doubt? The 4 options are there.
Sir, I am not understand the question itself.
So, okay. So
Which
then
function we are talking about? There is a continuous function f from 1 to 5
to
1 to 7. Sir, this is the domain or range of the function?
see from in the first option, it's saying there exists a continuous function f. Okay.
Yes, sir.
F from what? 1, 5, right?
Yes.
To something, right? To
Yes.
maybe it's 1, 7, right?
Yes, sir. 1, 7.
Yeah. From this means this is the domain. Right. And this is the codomain. It basically saying whether you have a function f, right? 1, 5 to 1, 7, okay,
Yes,
which
sir.
is continuous, and it takes 3 to pi. Is it possible, right? It's basically asking whether you have a function f from this to this, and as well as this function is continuous, and also it takes 3 to pi. Okay, is it possible?
Yes, sir. 3 is also lie in the domain.
What
Pi
is that? What is that function?
constant function, right?
Correct. If you consider this constant function, okay, let's say you take the constant function f of x equal to pi for all x in your domain, right? This is a continuous function, correct?
Yes, sir.
And as well as this takes 3 to pi. And similarly, you can try other option. Okay, this is slightly easier. Other options are slightly trickier. Okay.
So third and fourth option, can you please explain?
There exists a non-constant continuous function, okay, from
Yes.
R to R, which is bounded. Okay. Third option, basically what it says, you have a function, whether you have a function from R to R, okay, right,
Yes,
which
sir.
is continuous, okay, as well as non-constant. It's not a constant function.
Non-constant like sin x, cos x, maybe.
There exists a, yeah, continuous, non-constant. Okay, just me. Continuous, non-constant, and bounded. Right.
Sin
Whether
x is
you,
also,
yeah,
sin
correct, correct. Sin x, cos x, they're continuous as well as non-constant, and also as you can see, sin x is bounded because sin x is less than equal to 1.
Sir, fourth option,
Fourth option, you try to think.
there is unbounded quantity.
There exists a unbounded continuous function from where to where?
Unbounded like tan x.
But tan x, you have to see when you are saying tan x, then see it's not from anywhere to anywhere. Okay, some specific domain is given, right?
Yes, sir. 2 to 3.
So do you think tan x is unbounded in this domain?
No. Oh, y is equal to x.
F of x equal to x.
Yes, sir.
This is on. Do you think this is an unbounded function in this domain?
No, sir.
Think about this one. 1 by x minus 2.
Yes.
Do you think, no, now, do you think this is unbounded?
Yes, sir. Yes.
See, the main thing is here, as you can see, 2 is not included, right?
Yes, sir.
So we are in the safe situation because this function, certainly we are not including 2. But when you come closer and closer to 2, this will go towards infinity. So that means this is not bounded. And as well as this is continuous.
Okay, sir. Got it.
Yes.
If
Yeah. Pradeep Kumar.
Hello, sir. Hello, sir.
Yeah.
Yeah. Sir, I have some question in activity 8.1 and some 8.2. So in 8.12, like there is an option limit extends to 2 minus f of x equal to 10. Yeah, so that 10, I mean, it shows it's a correct answer, but 10 is not in that graph, right? Because as per the graph, the first graph, it shows that it's like a parabola and it's passing through the 0.6, right? But it's showing as 10, so I was not getting that quite clear.
No, this passing through 6 when at x equal to 0, right?
Yeah.
But what it's asking to find out the limit at 2, right? This is your 2, right?
At 2, okay.
This is 2, right?
Okay, at 2. Okay.
So if you go along this vertical line,
yeah,
this is where this, in some sense, this crosses the graph, right? And when you are coming to 2 from left hand side, okay, as you can see, the value of the graph, okay, it's going towards 10, right?
Correct.
So 6 is something different. 6 is here. It's the value of the function at x equal to 0. This is 0.
Okay, got it. Okay. Okay, and the third question, sir, in the same thing, activity 8.1, like, is there a way how we approach this problem? Because, I mean, what I did is like, I was trying to check the values, manually, and then I was just trying to check.
If x is greater than equal to 1,
yeah.
then this is what? X by x plus 1 times x plus 2, right?
Right, yeah.
Just a minute, let me share the screen. So right, this is how we define this function, right? So what are the problematic part for this function? X by x plus 1 by x plus 2. Can you tell me?
Sorry, I didn't get the question, sir. Problematic part.
So if you see actually at -1, -2, this function is not defined, right?
Yeah, correct. That is 1 by 6 constant, right?
No, I'm saying about this expression. Okay.
That expression, okay.
Yeah, but the thing is that will not create any problem because
the condition is greater than 1.
Correct, because the condition is greater than 1.
Correct.
Right? So if x is greater than 1, then basically you are in some polynomial by polynomial, right?
Correct. Yeah.
So that means if x is greater than 1, then you are in this part and this is a continuous function, right?
Correct. Yeah.
And when x is less than 1, then you are basically, this is a constant function, right?
Yeah.
So again, constant function, this is continuous, right? So the only problem is at x equal to 1, right? So at x equal to 1, you need to check whether this function is continuous or not, right?
Okay.
So for that, what you need to check? You need to check first. You need to find the left hand limit, right?
Okay.
right? So you have 1, you are coming. So the left hand limit means you are coming to this 1 from the left hand side, right?
Yeah.
And when you are coming to this left hand side, that means the value of the x is actually less than 1, right? The approaching
Correct,
when you are up. So when x is less than 1, what is the value of the function?
1/6.
1/6, right?
When x is approaching from 1,
From the left hand side, right? You are coming to x, coming to 1 from the left hand side, right? That is what the left hand limit is, right? You are basically checking when you are coming to 1 from the left hand side where your f of x approaches, right? That is the definition of left hand limit. So when you are coming to 1 from the left hand side, that means you are coming using some number which are less than 1, right?
correct.
So in that case, when you are using some x, okay, which are less than 1, in that case, the value of the function, this f of x, is 1/6, right?
When x is less than 1, it is 1/6. Okay, which means, like, I mean, since we are approaching to 1, we substitute x equal to 1. That's what it is, right?
The value of the function is 1/6. Okay, that
1/6.
is what we are substituting. Okay, because we are coming to 1 from the left hand side, that means the value, this x is less than 1. And in that case, if x is less than 1, in that case, the f of x is 1/6.
Correct.
So that means this limit is 1/6.
Okay.
Okay. And similarly, you need to compute the right hand limit, right? Again, the same logic. So right hand limit means you are coming to 1 from the right hand side of 1, right?
Yeah.
So here x is, so when you are coming to 1 from the right hand side, that means your x, whatever number you are using, all these numbers, they are greater than 1, right? And in that case, the value of the function is what? Right?
Okay.
And when actually x approaches to 1 plus, this is what? This is nothing but 1 by 1 plus 1 times 1 plus 2, right? This is 1/6. So the left hand limit and the right hand limit, they matches, right? And both the things are same, and also this is same as f of 1.
Okay.
Right? That means the function is continuous at x equal to 1. Okay. So in particular, the function is continuous on all the points in its domain, right?
Okay.
So then probably the answer will be, what is the question? The number of discontinuity will be 0, right? Because it's basically continuous everywhere. Okay. There is no point at which the function is discontinuous.
Okay.
Yeah.
Okay. I mean, I'm getting confused with this approaching from left and right. So probably, like I say, just another example. Like, take the question number 8 in this activity.
Okay, so again, like I'll suggest, if you are getting confused with this left hand limit and right hand limit, then probably question number 8 is not a good place to start with. Okay, but still let me do it. You should, in that case, you should mostly, I guess you should revisit week 7 concept.
Okay.
E power This is 0, right?
Yeah, x equal to 0.
So, okay, so again, the same logic, right? This function is actually continuous. It's clear that the function is continuous at all points except 0. Okay.
Yeah.
So the only from the definition it's clear. So the only point is you need to check at x equal to 0.
Yeah.
So at x equal to 0, you need to find the limit of this function, right? So first, let me start with the left hand limit, right? The left hand limit. So as h tends to 0 negative. Okay, not h. As x tends to 0 negative. Again, that means what? You are coming to 0. This is your 0, right?
Yeah.
You are coming to 0
from the
left hand side, right? In that case, where 1 by x will go?
It's coming from
minus infinity.
minus infinity.
Yeah, minus infinity. Because see, you are coming to 0 from the negative side of 0. That means all the number, okay, all the number you are using, they are negative, right?
Yeah.
So if you have a very small negative number, right, then 1 by that small negative number will go towards minus infinity, right? Because if you have 1 by minus 0.000001, it is a large negative number, right?
Correct. Yeah.
So 1 by x will go towards minus infinity, right? Then where this e power 1 by x will go?
0.
Okay, so whoever actually asked this question, it's better if you answer. Okay, other don't answer.
Yeah. Okay.
So see, if this is going towards minus infinity, then this basically what? In some sense, this will go towards e power minus infinity, right? So this is 0, right? Correct?
E power minus infinity extension. Okay, e power minus. Okay.
See, 1 by x is going towards minus infinity, right? That means e power minus x, like, certainly it's not correct, but you can say certainly it should go towards this e power minus infinity, right? So, and what is this thing? Okay, e power minus infinity. So, okay, so mathematically it's not correct, but yeah, but you can say this e power minus infinity is what? This is 0, right? So this e power 1 minus 1 by x will go towards 0, right? That means e power minus 1 by x plus 1 will go towards 1. That means 1 by e power minus 1 by
x plus 1. So you 1.
Okay, I made a mistake. This is not minus. E power 1 by x plus 1 will go towards 1, right?
Okay.
So this is your left hand limit. So what basically we have computed? We have computed when x is coming to 0 from the left hand side, where my f of x is going, right? This is my f of x. Okay, and what basically we have computed, when x is going towards 0 negative, my f of x is going towards 1, right? Then the next thing is, this is your left hand limit, right? The next thing is the right hand limit. Now, when x is going to 0 positive, right, where this 1 by x will be? Sorry?
It's going to 0 positive.
That means you are coming to 0
Ah,
from the positive side of x. Okay.
yeah.
Positive side of this line. Okay. So here you have positive. Then where 1 by x will?
For higher numbers, it will approach 0.
How come? See, x is very small, right? X is very small and positive, right? That by
Okay, approaching 0. Okay.
yes, x is approaching to this 0 from the left hand side, right hand side.
Okay, okay, then infinity.
Yes, correct. This will go to plus infinity. X is very small and positive. That means 1 by x is positive and as well as very large.
Okay.
So if this is going towards plus infinity, then e power 1 by x will go towards
0.
no.
Sorry,
See
infinity.
infinity, same logic, right? See, here 1 by x was going towards minus infinity. That means e power 1 by x will more or less go towards e power minus infinity, because here 1 by x is where you need to check where 1 by x is going. According to that, you have to replace it. Right? So here e power 1 by x, in some sense, it will go towards e power infinity, right? Which is infinity.
Yeah.
Right? And similarly, you can say that 1 plus e power 1 by x, you are just basically adding. This will also go towards plus infinity, right? So if this is going towards plus infinity, then where this will go? 1 plus e power 1 by x. This will go towards 0, right?
Okay.
See, it's basically the same thing, right? If you have 1 by x, when x is going towards plus infinity, this is going towards 0, right? This is too large. That means the reciprocal will go towards 0. The same thing happening here. This part is going towards plus infinity. That means the reciprocal will go towards 0. Right? So this is your right hand limit, right? And the left hand limit is 1 and your right hand limit is 0. They are not same. That means the function is not continuous at x equal to 0.
Okay.
So again, like I see, if you have problem with this left hand limit and right hand limit, then I'll suggest try to spend some time on week 7.
Okay. Okay, sir.
Yeah.
Okay, thank you.
Yes. Okay, anything else?
Yes, sir. One more doubt I have.
What is that?
8.1 question number 6. How we have to reach the function? What is a function? Then we are talking about continuity.
No, you don't have to reach you just need to know the property of the function. Okay, you have a function, right? The function satisfies some property, right?
Yes, sir.
So you just need to use that.
Sir, can you explain, sir? I'm not getting that.
No, you try this question 2-3 times more, then probably I will try to explain. Okay. See, before that, let me just give you some hints. Okay. So I will not explain the question.
Okay, sir. Hint, can you give me a hint?
See, what it's basically it's saying, c times x is f of cx is what? C times f of x. And this is what? This is true for all c x inside R, right?
Yes, sir.
So that means this is true for any arbitrary c, for any arbitrary x, right?
Yes, sir.
So I can, if I have f of 9, then I can write this as 9 times f of 1. Correct? Because
yes,
what
sir.
is this? F of 9 is what? 1 times, 9 times 1, right?
Yes, sir.
And if I treat this as c, this as x, then I can write this, right? So in particular, f of x is what? X times f of 1, correct?
Yes, sir.
So this function is completely determined by the value of the function at 1, right?
Yes, sir.
So now you need to check the limit. Okay, to check the limit, what you need to check? You need to basically show limit to show that this function is continuous at x equal to c, right? You basically need to show that as limit extends to c, f of x is what? It's f of c, right?
F of c.
Now you are in, now you can replace this f of x by this quantity, right?
Yes.
Then you try. It's really easy, right? You can take take f of 1 out, then basically you basically left with x here. Okay,
Yes.
f of 1 times limit extends to c x, right?
Yes,
And what
sir.
is that? This quantity is what?
X.
Right? F of times this. What is this? This is c, right? F of 1 times c.
Yes.
Limit extends to c x. What is this? This is c.
Yes, sir. Yes.
And again you apply the property of this function. This is nothing but what? This is f of 1, f of c.
F of c. Yes.
So you are getting this, the limit is precisely f of c. That means the function is continuous at c. That means this is a continuous function. Clear?
Okay, sir. Yes,
Yeah.
sir.
Any other doubt?
Hello, sir.
Yes.
I have a very basic question.
Hmm.
That is with respect to this question number 4 of assignment 8. So that already you have discussed. But if I consider the first, the figure that was given where there were two straight lines where they were intersecting at the origin. Now, in place of two straight lines.
Sorry, like your voice is not clear to me. Like some.
Okay, sir. Can you now hear my voice?
Yes.
Sir, my question is with respect to this assignment 8 and the question number 4 of assignment 8. In the first,
it's breaking. It's there is a continuous breaking in your voice. Okay. Which activity problem or practice assignment problem?
that was assignment problem, sir.
No, assignment which problem? Practice assignment activity or graded which one?
Graded one. My doubt is, sir, with respect to the first figure where there were two straight lines where they are intersecting at the origin. Okay, so now in place of two straight lines, if there is only one straight line and suppose that is passing through the origin, so in that case, sir, like you have said that that particular curve or the line, whatever it is, it will have the tangent point provided we can differentiate the function. Right. So suppose if there is only one straight line, and in that case, I'll be able to differentiate that particular equation, right? So in that case, sir, the tangent to that line will be the line itself.
See, the tangent line is basically what? It's it's basically how you compute the tangent line. After you know the derivative of that function at that point, right?
Yes.
So that is how you are going to compute all the tangent lines. So the functions are given, right? All the functions are given, right? The thing is you need to find the tangent line of this function, right? At x equal to 0.
No. My question is with respect to the tangent point of a straight line, sir.
There is no tangent point of straight line. Okay, there is a tangent line of a function at some point.
Suppose the equation of the straight line, that is y is equal to mx plus c. So now first thing is that I'll be able to differentiate it if I come from that point, right, sir?
Yeah, you can differentiate this line. Yeah.
Okay, so that particular condition is satisfied. So in that case, can I say that the line itself will be the tangent of that particular line?
Yeah, yeah, correct. Line is a tangent to that particular line. Correct. Yeah, that is correct.
Okay, and suppose when we have said that when these two lines are intersecting at the origin, we have said that at that particular origin, 0, 0 point will not have the tangent because there are two equations to represent that particular plot. Is it that particular point from which we can say that will not be able to get the tangent
Again,
point
like, sorry, like I am not getting your question. It's breaking continuously. It's not very difficult for me to decode what you are saying.
Can tangent line intersect the curve?
Tangent line, yeah, it can intercept the curve, right? This is what if you see this graph, okay. So you, for example, you see this graded assignment, this question. It's basically intersecting the.
Yes, sir. Y is equal to x cube at origin.
Yeah,
tangent line intersect the y is equal to x at origin.
Yeah, of course it can. Suppose you take this. See, it's you take this. Let's say suppose you consider this graph, okay, this. So if you take this tangent, so it can intersect the curve, right? It's basically intersecting the curve at this point, okay.
But it touches the curve, not intersecting.
No, this, what you mean by touches the curve? It's basically intersect the curve here, right? It basically intersecting the curve at this point. See, it's very when you are computing this at this point, okay. So in a very small neighborhood of A, it will not cut the curve, okay, but it can cut somewhere else, right?
Okay.
Here, if you see this point, here it's actually it's cutting the curve. That is what you are asking, right? Whether a tangent line can cut the curve. Okay.
Okay, sir. Thank you.
Yeah. If you are computing at a point, so in a very small interval containing that point, it will not cut the curve. It will basically touch the curve. Okay, at that. But it can cut the curve at some other.
No, sir. I am talking about the intersecting of the tangent line at x equal to a.
See, at that point, it will touch the curve.
Yes,
It's
not
near. Yeah. That at that point, certainly it's not how it's going to intersect. It has to touch because the line passes through that point, right?
So in general, at a x equal to a, it touches the tangent line touches the curve.
Yeah.
Okay, sir. Thank you.
Yes. Any other doubt? Okay, then I'll stop the session. Okay.
Thank you, sir.
Thank you. Yeah.
Thank you, sir.
Yes. Thank you.
Thank you, sir.
Yes.